So let's just take one step back. We're talking about the wind stress. So the wind stress is it's a directional frictional force operating along the surface of it. Okay, it's a two-dimensional vector, and a vector is something that has a certain magnitude and a certain direction. Okay, and you can show vectors using arrows in diagram. And here's a little diagram that shows you a wind stress, which can be expressed by two components. One component in the zonal direction, in the x direction, and the other component in the y direction. So 1.1 into the east direction and 1 into the north direction. Okay, and this is how you represent a vector. And the vector is often shown with a little arrow on the head. It's tau, the symbol here. So the wind stress can be derived from measurements of wind velocity, horizontal wind velocity. And for ocean applications, we usually take a reference height of 10 meters above the surface. Okay, and then we can use a so-called empirical formula to calculate the wind stress. Okay. The magnitude of the wind stress is actually proportional to the wind speed squared. So the higher the wind speed, the higher is the wind stress. It's a disproportional, it's a nonlinear relationship. Okay, and the next step is if we have a wind stress, we're operating on time scales exceeding a few days, so you're on longer time scales. The action of the wind creates Ekman layers in the ocean. They're only 50 to 100 meters thick. So the average volume transport, called Ekman transport, is perpendicular to the wind direction. Okay? And it's to the right in the northern hemisphere and to the left in the southern hemisphere. But you can also quantify it. There's an equation. You can plug in the wind stress magnitude. You plug in the seawater density. Seawater density is pretty constant, and something we know as we call the Coriolis parameter. It is a function of the geographical latitude. And then you can even work out how much water is transported within the Ekman. It's the volume transport. Cubic meters per second is the unit. Okay. And I make this point here with a formula so that you know that you can work out the Ekman transport, and from that you can even calculate something that we call the wind stress curve. But we come to that on the next slides. All right.